Welcome back. In this video, we are going to solve problem 13-19 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. So statement is determine the maximum force P that can be applied to handle so that A992 steel control rod AB does not buckle. The rod has diameter of 1.25 inch. It is pin connected at its end. So you can see the figure shown in problem 13-9. This is the rod where this is the handle where a P load is applied, and due to this P load there will be a compressive force in this rod AB, and that you have to find this largest load that can be applied without causing a buckling in this rod AB. So let's start with the solution. So from this figure you can see when you applied this load, so it will cause compression in this. As a result, if you take this handle and draw the free body diagram, so the load offered by this member AB on this handle will be upward. So we will draw the free body diagram of handle. So for that, if I assume this handle is like this, clear, and at one end we have load P, clear, and this is your point C, for example, at end. So you can see the end is pin supported. So when you remove this pin support, so you will be having a horizontal reaction force as well as will be having vertical reaction force CY. And this is point A where you have a vertical load that will be offered by this member AB on this handle. So the distance from C to A is given as 2 feet. This distance is 2 feet, while the distance from this C till end is 3 feet. Okay. So we will apply equation of equilibrium. The equation of equilibrium will be sum of all moment about point C is equal to 0. Why? Because we are interested to find out this FB. Clear? So the first force which is producing moment about point C is this load P, and perpendicular distance is 3 feet, and this is producing clockwise moment. So this will be negative. So I can write minus 3 times P. The second moment due to this load FAB into perpendicular distance is 2, and this is producing counterclockwise moment. It will be positive. So plus 2 FAB is equal to 0. Okay. So from here, what we will get, we need FAB. So 2 FAB is equal to 3P, and FAB will be equal to 3 over 2 times P, or you can see that we are interested to find out the largest load P on the handle that can be applied. So it will be 2 by 3 FAB. Okay. So this is our load. Now we know that using Euler's formula, we will find the maximum load that can be applied on this column AB can be written as P critical, which is the maximum load that it can bear without bucklings, that is equal to pi square E times I divided by LE square, where LE is effective length, I is the moment of inertia, and E is modulus of elasticity, and LE is equal to KL. Now what is the K? K is a factor and can be obtained from the book. It is given that pin ended at both sides. So for that K is equal to 1. I will go towards the book and I will show you where it is given. So here you can see the first scenario is pin ended. K is equal to 1. So K is equal to 1, and length of this rod is 3 feet. So 3 feet, and when you convert it into inch, so 3 multiplied by 1 feet is 12 inch. So this will be 3 into 12, which will give you 36 inch. Okay. So this is effective length. Now what is the moment of inertia I? So for cylindrical rod, the I is pi by 4 times C power 4, where C is the radius. So pi by 4, radius diameter is given as 1.25. So radius will be 1.25 divided by 2, which is 0.625. So 0.625 power 4. So we will calculate this I. So I is 0.625 power 4 divide by 4 multiply by pi, which is 3.1417. So you can see this is 0.140 inch power 4. Let me check it again. 0.625 power 4 multiply by 3.1417 divide by 4, which is 0.199. Sorry. So this is 119. 0.119. Now in this formula you can see we have I, we have LE, we do not have E. So E will be taken from the property table, as well as we will get the yield stress. So it is given that this is A992 steel. Clear? So you will go to the book, and in book you will go to the end average mechanical property, and that will be in US customary, and you can see it is already highlighted. A992 steel having E is 29 into 10 to the power 3 KSI, and yield stress is 50 KSI. So I will write this value. E is 29 into 10 to the power 3 KSI, and yield stress is 50 KSI. Now you have all the values, just plug it in this formula. P critical is equal to pi square. E is 29 into 10 to the power 3 multiplied by I is 0.119 divided by effective length, which is 36. So 36 square. So we will solve this and we will get the P critical. So pi is 3.1417 square multiplied by 1417 square multiplied by 29 multiplied by 1000 multiplied by 0.119 divided by 36 square, and that is equal to 26.28 kip load. 26.28 kip load. Okay, so this is the maximum load that this rod AB can bear. So we can write that FAB, which is the maximum load in this rod AB, will be equal to P critical, and this is the main point in this question, which is 26.28 kip. Now we know that this P, which is load on the handle, is equal to 2 over 3 times FAB. So you can see 2 over 3 multiplied by 26.28 will yield you the load, maximum load on the handle that will not produce any buckle in rod AB. So 26.28 multiplied by 2 divided by 3 will give you 17.52 kip. Clear? So this is the answer, but before answer I will check whether this load is producing any buckling effect in this rod or not. For that we will need critical stress, and critical stress is equal to critical load divided by the area. So critical load is 26.28, and area, since this is circular rod, so its area is pi r square or pi c square, and that is 26.28 divided by pi multiplied by 0.625 square. So that will give you critical stress. So 26.28 divided by 3.1417 multiplied by 0.625 square, and that is, you get critical stress is 21.34 KSI. Okay, now we have this critical stress. We will check whether this answer is correct or not. So for that we must know that critical stress should be less than yield stress for Euler's formula validation. So if this is validated, then our answer is correct. So you can see the critical stress is 21.34 KSI, and that is less than yield stress, which is 50 KSI. So it means our value of the load on the handle, which is 17.52, is correct, and this is the load that can be applied on this handle. P is equal to 17.52 K's load that can be applied on this handle without causing buckling in this rod AB. And that was all about problem 13-19. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.